It's only the even numbers, I think. I'm hoping right. On both sides, so it shouldn't take us that long. Okay, let's figure out how to work this. Okay, seriously? Let's try again. Okay, seriously. Alright. Okay, let's just wasted 10 whole minute of your life. Sorry about that. Let's try again. And we're live. And even numbers, I believe. So this is, again, here's your decimal. You want to change that and write it in scientific notation. So I know that this is going to be positive again, positive exponent. So let's see what the first factor is. Let's move the decimal 1, 2, 3, 4, 5, 6. So it's going to be 10 to the 6th power, and my first factor, remember, has to be a number between 1 and 10, so it's going to be 5.4 times 10 to the 6th. The next one, this is going to have a negative exponent, right? So let's see, it's going to be 1, 2, 3. It's going to be 9 times 10 to the negative third power. Again, another negative exponent, 10 to the negative something. So again, let's see, 1, 2, 3, 4, 5, 6, 7. It's 2 times 10 to the negative 7th power. Okay, and you can always verify that if you want to change that. So again, 2 times 10 to the negative 7th power, remember laws of exponents, we can change that to 2, 1 over 10 to the 7th. And then you can do 2 over 1, 1, 2, 3, 4, 5, 6, 7. And you can divide that up, and you double check if that equals that. Okay. Is that it? No. 8, 10, and 12, and 14. Okay, so that's definitely not in scientific notation, right? So we got changes in scientific notation. Well, 71 times 10 to the third. Well, 10 to the third is 1, 2, 3. So this would be 71,000. If you want to multiply it out and then change it, to scientific notation. So you could have done that, and then this would go, and here's a decimal at the end, so we go 1, 2, 3, 4, which would be 7.1 times 10 to the 4th. If you didn't want to do that, you could have just, again, adjusted the original problem. So here's 71. 71 has a decimal here. We moved 1 to the left to get 7.1, and then because we moved the decimal 1 over, we would increase that 10 to the third to 10 to the 4th. Up to you how you want to do it. Again, negative exponent, negative something. So 1, 2, 3, 4, 5, 6, 7. 9 times 10 to the negative 7th power. 12. So if you think about this, again, I don't know if it's easier for you to do that. 33 times 10 to the negative third is 33 times 1. And 10 to the negative third becomes positive 33 times. And then there's to the 1,000. So that really becomes 33 over 1,000. If you think about what that is 0.033. That's what that looks like, right? So we're going to adjust. So I made all that to change to this. And now I can adjust that, right? And change to scientific notation. So we're going to move the decimal 1, 2. So it's going to be 3 to the third, 3.3 times 10 to the negative 2nd power. Now, you could have done the same thing here, right, and adjust right over here and make that 33 into 3.3, right? And then you could have, in this case, you'd have to, instead of 10 to the negative 30, you'd have to decrease 1 and make it 10 to the negative 2nd power. Okay? So you have two choices here. So this one takes a little bit more getting used to it. Okay, once you see it, I guess it's easier. 0.0042, we're going to move the decimal 1, 2. We're going to put it between the 4 and the 2 because the first factor has to be a number between 1 and 12, 1 and 10. 0.42 times 10, and how many times do we move the decimal? 1, 2, 3, negative third power. 16 is the last one. Okay, so this is already, well, at least 4.8 is already in the format that we want. So we're going to just write times 10 to the 0 power. We didn't move the decimal anywhere, so, and 10 to the 0 power is just 1, and 1 times 4.8 is 4.8, so we're good. My music selection today. Jeez. Okay, so 2 times 10 to the negative first power. We're going to write that in standard notation. So this is going to be, here's a 2, here's where's my decimal. In this case, we're going to move that way because it's a negative exponent, right? So it's going to become 0.2. And again, just to show you, that's the same thing as 2 times 1 over 10 to the right to the positive first power, right? Laws of exponent, which can change that negative exponent. We just bring as a reciprocal and change the negative exponent to positive exponent. And then that becomes 2 over 10, which, as you know, is the same thing as 0.2. Okay. 804 times 10 to the second power. Write the number in standard notation. So, first of all, that's not in scientific notation, but it's okay. So 804, think about what 804 times 10 to the second power, which is 100. Right? So literally the only thing we have to do is move the decimal 2 over to the right, 1, 2, and we get 80,400. Okay. One 1.5 times 10 to the second power, so 1.5 times 10 to that, here's 1.5. We're going to move the decimal, it has to go that way, right? Because it's a negative exponent, so we're going to go 1, 2, and in standard notation, 1.5 times 10 to the second power is 0.015. Okay. 24. 8 times 3 to the 8 times 3 times 10 to the 7th power. So it's 8 times 3. We're going to move the decimal 7 over. 1, 2, 3, 4, 5, 6, 7. 0, 0, 0, 0, 0, 0. Let's clean that up. No idea what that is. 3, 1, 2, 3. So that looks like 83 million. 1.71. Move the decimal 7 to the right. 1, 2, 3, 4, 5, 6, 7. So we're going to add 1, 2, 3, 4, 5 zeros, and that becomes whatever number that becomes. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 17,100,000. 38 times 10 to the second power is going to be 38. Think about it, times 100. And to 38, it's going to be 3,800. Okay, so, and you think about every time we move, if you multiply by 100, it just means that we're moving the decimal 2 spaces to the right. Four times 10 to the 0 is just 4. Oh, that's easy. And the last one, 4 times 10 to the negative 5. So here's 4, here's the decimal. We're going to left, right? Because the negative exponent, we're going to go left. 1, 2, 3, 4, 5. All right, to the 3 people or 2 people that are watching this video, 0.00004. That's it. Very simple.